in. We'll be sharing this via email in our post-event survey, and we'll give you the link to our YouTube VEX Robotics Asia Pacific channel. So without further ado, let me go through a couple of new really important things that we've updated everybody with our hardware. So with VEX Robotics, what's very unique is that we have a continuum, a progression, an order of educational robotics platforms that go from entry level, intermediate, all the way to advanced. Some of the new platforms that we have is VEX EXP, which was designed for the classroom. And we also have the VEX V5 Work Cell, which is a little bit different because it's not a mobile robot. What it is a desktop application with a 5-axis robotic arm, but it's to make the introduction from education into career.
有了，我知道了。
Okay. For those, again, just joining, if you please don't mind to mute your microphone for the benefit of others. Thank you. So about our hardware, what we will be introducing and talking mostly about today is for the VEX Robotics Competition, the V5, but there are many other platforms and updates. The VEX EXP is an introduction to metal robotics construction platform. It's more robust. You can build a robot more quickly, program, code it, drive it, and then be able to disassemble it. So for your budget, you'll be able to get more students introduced to the world of metal robots. Also, another update from our software side, we have the VEX Code VR. This is our computer science platform and curriculum continuum that provides students with a fun and engaging way to learn authentic applications to computer science concepts with a virtual robot. So we have lots of platforms for both block-based coding, Python, and as well as a lot of activities. So these courses are student-facing, and teachers would help as facilitators. And then we have some quizzes and project challenges that would allow you to have formative and summative assessment. Starting this fall, we're going to have a pay-for VEX Code VR Enhanced and Advanced available for purchase. So this is something that's important if you're looking to further your computer science curriculum and your training. So about curriculum, we now have VEX EXP and VEX V5 WorkCell STEM Labs. So STEM Labs curriculum was designed as a supplemental educational resource. It's based on research and studies, and it's developed by our talented team of former teachers. So we bring together current research and classroom experience to create comprehensive teacher tools and training to ensure teachers are prepared to succeed with our technology, our curriculum, and our pedagogy. So STEM Labs is free. It's easy to follow, and these STEM lesson plans with teacher support materials, teacher notes, pacing guides, and student-facing presentations will allow you to be able to teach and be able to promote STEM education in your school or your program. Now, another important point about our VEX Robotics certification is that we also have teacher certification for EXP as well as VEX V5 WorkCell. So as you may know, there's been a rise in demand by teachers for micro-credentialing. And this is very important that teachers can select and learn at their own pace these short form micro-credentials that might be tailored to their career goals or their education goals. So we have lots of material to be able to show you how you too can gain the confidence to be able to teach and be able to build the capacity at your institution. Last but not least, we have VEX PD Plus. This is brand new, and it's a community learning platform that enables educators to learn from and interact with experts in classroom and competitive robotics. So if you are a coach, if you're a teacher, if you're a mentor, you may want to check out VEX PD Plus because it's a network of resources and you can receive year-round coaching and feedback from the VEX education experts in our global network. PD Plus members are also able to experience the most inspiring STEM education event with our Educators Conference. This will be held at our VEX Robotics World Championship, which will be in Dallas, Texas, United States in April 2023. So our competition season is just started, so we have so much more to expect. Please check out pd.vex.com, and there's a 3-day free trial, so you can test out PD+. Also, just to let you know, we will be attending future events. So we'll be in Bangkok presenting at the British Educational Technology Show, BET Asia, in October, EduTech Asia in Singapore in November, and the Learning and Teaching Expo in Hong Kong in December. So if there's any events in the future that you think that might be useful to attend, please don't hesitate to reach out to us. So how you can reach out to us for any events related questions, please contact us at ap-events@vex, education training, ap-info@vex, or if there's any product or procurement questions, please email ap-sales. So without further ado, we're going to have Crystal give a discussion about the VEX Robotics Competition and introduce it to you if you are new to VEX.
Hi, good afternoon. In this session, I'll introduce the REC Foundation, VEX competition history, resources, and how to get started. VEX Robotics World Championship has been recognized as the world's largest robotics competition by Guinness World Records in 2016 and 2018, and the largest online robotics competition in 2021. After 2 years of suspension due to COVID, the in-person VEX World Championships returned to Dallas, Texas in May of 2022. This time, the VEX Worlds brought over 3,000 teams from 36 nations together to celebrate STEM's excellence. The VEX Robotics World Championship is organized by the REC Foundation, which is a non-profit organization. The REC Foundation manages all of the VEX competitions in the world and looks for the local event partners who will host VEX events for the local teams. REC Foundation also contacts possible sponsors supporting our events. VEX competition attracted many organizations. Northrop Grumman Foundation is the presenting sponsor of VEX Worlds. We have NASA, Google, Tesla, Dell, Omron, Autodesk as global sponsors. In Asia, we also have Alibaba, Tencent as our regional sponsors. VEX competition provides a variety of competition platforms from preschool students to university students. So far, VEX Go Challenge is a classroom competition based on challenges that provides young students with the opportunities to showcase their learning through participation in online challenges. Teachers register their classroom teams at robotevents.com to unlock the season challenges. VEX Go team member registration is free. The VEX IQ competition provides elementary and middle school students with exciting open-ended robotics challenges that enhance their science, technology, engineering, and mathematics skills through hands-on, student-centered learning. The VEX Robotics Competition is the largest and fastest-growing middle school and high school robotics program globally. Each year, an exciting engineering challenge is presented in the form of a game. Students, with guidance from their teachers and mentors, build innovative robotics and compete year-round. The Factory Automation Competition, FAC, is a classroom-based competition that provides students with essential and desirable foundational skills needed for today's advanced manufacturing careers. In this session, we'll focus on VIQC, VRC, and VEXU. VGOC and FAC introduction will be the fourth session of today. VEX competition started in 2007. VEX IQ competition started in 2012. We are now in 2022 to 2023 season. This season's games are Spin Up and Slapshot. If you are interested in the previous games, you can find out on REC website. There are different ways to compete in VEX competition. The traditional VEX competition events are held in person in a school or other public venues, with tournament, robot skills challenge, and judging. We also provide online formats for teams who cannot travel or gathering during pandemic. LRS is a live remote skills-only event. Online challenges give students more opportunities to stay engaged in virtual learning. Online challenges could include website design, CAD design, photography, community environment, video production, workforce development, programming, and much more. Every season, some online challenges items provide opportunities of VEX World's qualification spots. VR skills allow all teams to experience the fun and excitement of competing while learning computer science. Before start VR skills, teams must complete this season's team number registration. VIQC and VRC VR skills for this season's game are available now. In each country or region, teams can participate local events or scrimmages to improve their robots and competition skills before attending the national or regional championship events for the VEX World spots. Besides, teams can also choose Asia-level events and signature events. Both two options are approved by REC with extra VEX World spots, which is different to the spots than allocated to a given country or region. This is a suggested season timeline. In June 2022, we started the new season and hosted the new season kickoff webinars. During or after summer holidays, teams will start to order their new game elements, register or renew team number, design, build, program their robots, and record engineering notebook. From October to December, teams will attend some local events, scrimmages, to prepare or update their robots and get prepared for the qualification championship events. From December to March of 2023, teams can attend national or regional championship events, signature events, Asia-level events, and also online challenges to get qualified to 2023 VEX Worlds. All qualifying events in Global will be completed in March. Then, team can start to register VEX Worlds and plan travel. In 2023 April, teams from all over the world will gather in Dallas for the most exciting VEX Worlds and the new season game unveiling ceremony. These are useful resources for all the teams. The first one is the official REC Foundation website. You can download game rules and other useful documents. The second one, robotevents.com, is running by the REC Foundation too. Teams register or renew their team numbers, and event partner post their events, publish event results on this website. Every registered team has the opportunity to ask for official rules interpretations in the VEX IQ competition Q&A system or VRC Q&A system. All responses answered by the GDC game design community should be considered as official rulings. Teams and event partners can also look for help from VEX community through vexforum.com. We also have these apps and software for you. VIQC Hub and VRC Hub are the ideal competition companion for teams and event partners. You can read the game menu, keep score at home, and use the timer to run your own practice matches with official sounds. VEX VR allows you to follow the progress and results of VEX competitions. Teams can find the teams list, match schedules, match results, rankings, and skills challenge results, which can be sorted by events or by team. REC Foundation app shows VEX World's documents. Tournament Manager and TM Mobile are the official competition management software used by event partners and referees during VEX competitions. Referee uses VEX TM Mobile to submit match and scores from tablet. The REC Foundation and VEX have partners to provide free online training for event partners, head referees, judges, and VRC drive teams. These certifications include interactive and engaging learning resources to ensure you are prepared. For every course, the contents are divided into some units, and each unit has a practice exam before you go to the final exam. After earning the certifications, event partners and volunteers can be confident in their ability to host or perform the assigned volunteer role at VEX events. And all official events that qualifies teams to a championship event are required to have a certified judge advisor. However, all judges are encouraged to use this certification course for training. The courses will be available in summer. There are 4 steps to get started. Form a team, register team number, build robots, and attend events. There's no maximum to the number of students who can participate on a robotics competition team. Your team is more productive if everyone is assigned a role. Consider rotating roles so the team members can benefit from the full program experience. Assign or have the students choose the roles that best fit their interests, skills, and needs. Robotics team role suggestions are team captain, drivers. Normally, we should have 3 VRC drivers or 2 VIQC drivers. Designer, builder, programmer, engineer notebook manager, public relationships and advertising, and so on. Developing your team identity can be a valuable, fun part of the team building progress. Your team members should use their creativities to establish their own unique identity. Developing a team identity can include choosing a team slogan, name, creating displays for your kit, and designing a team shirt. Starting from 2022 to 2023 season, the team registration fee will be changed to a flat organizational fee format. That means an organization can register up to 22 teams for $650. For example, Organization 1234 has 1 team. The registration fee is $200. Organization 9876 has 2 teams. Their registration fee is $350. Organization 5678 has 4 teams. The registration fee is $650. Organization 4678 has 22 teams, and the registration fee is still $650. Please note, if Organization 3334 has 68 teams, they will pay 3 flat organization fees to cover 66 team registrations, plus 350 to cover the remaining 2 teams registrations. So the total registration fee is $2,300 US. Organizations within a single REC Foundation program are defined by the location of the host school or group and can be described using the following criteria. The first one, all teams within an organization reside in the same event region. The second one, teams within an organization meet together periodically throughout the season at a central or common location. The third one, each school in a district is recognized as a different organization and should have their own set of team numbers. The fourth one, each location of a private or community-based club is recognized as a different organization and should have their own set of team numbers. The last one, organizations with multiple grade levels that reside at the same location can elect it to be identified as a single or multiple organizations in a single program. If a school is new to VEX, then this school is a new organization and will need to register new team numbers. A team number includes a base number, which presents the school, and a letter, which presents a team at the school. For the returning schools, they will renew their team number registered in the previous season. No need to register a new team number. When teams are ready for an event, please go to robotevents.com, select the correct program, then they will find out events nearby. This is an event page. When the event is open, simply choose your team number to register the event. Please note, the event registration fee is set up by an event partner. For events in Asia, teams should send the event payment fee directly to the event partner. Do not process through REC website. But if you are registering VEX Worlds, please send the event payment directly to the REC through the website. The payment way is just like what you did for team registration payment. When a team arrives at a tournament, they must check in to let the event partner know they arrived. The coach receives the event materials or information, including badges, schedule, and pit map. Teams must go through a robot inspection to ensure their robots are in compliance with regulations related to size, parts, and field control guidelines. The driver meeting is typically run by a head referee or the event partner. All participants, including students, coaches, and other adults associated with the teams, are expected to attend. In this meeting, rules and safety regulations are reviewed. Event information, like where to line up or any adjustment to the schedule, are also provided. As part of many events, judges review all submitted engineer notebooks, observe team performance, and conduct team interviews. The qualification match schedule is available once all teams are checked in. This schedule shows the randomly assigned alliances and qualifier matches pairing of teams. During most events, teams have an opportunity to participate in robot skills matches. These are usually held on a separate field. In VRC events, after the qualification matches, the top scoring teams choose their alliance partners for the elimination matches. Then, top teams will go to finals to determine champions. At the closing ceremony, event partner will issue the awards and celebrate team's performance. Okay, this is the end of this session. The next one is the new game rule analysis.
Okay, well, thank you so much, Crystal. Now we're going to share with you about the VRC spin-up game analysis. This is what you've all been waiting for. Here we have Jason Kang, Regional Events Director.
Good afternoon. Welcome to the Asia Pacific 2022-2023 VEX New Season webinar. For this session, I will introduce the new VEX Robotics Competition game, Spin Up. First of all, I would like to share how VRC game is played. The VRC on-field game including head-to-head match and skills challenge match. For head-to-head match, the match time is 2 minutes. There are 2 alliances, one red and one blue, composed of 2 teams each, compete to each other. Robot Skills Challenge is just 1 team and the match time is 60 seconds. Besides, there are more options for VRC program, such as Judge the Award, which you will need to prepare engineering notebook and judge interview. Online challenges offers team more opportunities to showcase their work through a variety of online submission topics. Virtual skills allow all teams to experience the fun and excitement of competing while learning computer science. The VRC game is played on 12-foot by 12-foot field. Normally, the field won't change every season, just game element need to update. The head-to-head match has following key points. 2 alliances, one red and one blue, compete in a match, and 2 teams per alliance. For each match, there are 3 driver team members for a team, and 1 robot per team. The figure shows a match last season. There are 4 robots on the field from both alliances, and 6 students from Red Alliance, 3 per team. The match time is 2 minutes, which contain a 50-second autonomous period and a 1 minute and 45-second driver-controlled period. Teams in the same alliance will receive the same point for each match, except disqualification. Teams will be randomly assigned an alliance partner to compete against 2 randomly assigned opponents in each qualifying match. Team will be ranked based on the same number of qualifying matches, and the process is teams will play qualifying matches first. Then the higher ranking teams will select their fixed alliance partner for elimination matches. Then elimination matches will be played according to the elimination bracket. The qualifying match schedule will be available prior to opening ceremony on the day of competition. This schedule will indicate alliance partners and match pairings. It will also indicate the alliance's color, red or blue. For tournament with multiple fields, the schedule will also indicate which field the match will take place on. All teams in each qualifying match will receive win points, WP, autonomous points, AP, and strength of schedule point, SP. Team rankings are determined by the same number of qualification matches. WP is the first basis of ranking teams. Teams will receive from 0 to 3 WP for each qualification match. AP is the second basis of ranking teams. An alliance who wins the autonomous bonus during a qualification match earns 10 AP. In the event of a tie, both alliances will receive 5 AP. SP is the third basis of ranking teams. SP are equivalent to the score of the losing alliance in a qualification match. In the event of a tie, both alliances receive SP equal to the tie score. Before elimination matches, there is an alliance selection process for the higher ranking teams at the end of qualification matches to choose their permanent alliance partner for the elimination matches. After the alliance selection is finished, the elimination matches will be played according to elimination bracket. The number of alliances in elimination matches is decided by the event partner according to the event capacity and schedule. Elimination matches are a blend of best of 1 and best of 3, depends on division setting and VEX World Championship spots allocation. Let's take a one division tournament that directly qualify teams to VEX World Championship, for example. Elimination matches before the finals are best of 1. Final matches are best of 3, which is 2 wins. Robot Skills Challenge is another way to play the VRC game, which has following key points. 1 team in each match, with 3 driver team members and 1 robot. 60-second match time, including driving skills matches, which will be entirely driver controlled, and programming skills matches, which will be autonomous. It is optional for an event, and is first come first served, no match schedule. Teams will be ranked based on the sum of their highest programming skill match score and the driving skills match score. Okay, now we know how VRC game is played. Let's see the game unveil video for the new season.
Welcome to the 2022-2023 VEX Robotics Competition season, and this year's game, VRC Spin Up. VRC Spin Up is a head-to-head game that is played by 2 alliances, one red and one blue, made up of 2 teams each. The primary game objects in VRC Spin Up are yellow foam discs. Discs are 140 millimeters in diameter and 20 millimeters thick. There are 60 discs total in a spin-up match, 38 that start on the field, 2 preloads per robot, and 7 match loads per alliance. Discs can be scored in the 2 high goals, 1 per alliance, at opposite corners of the field. Each disc scored in a high goal is worth 5 points. However, robots that are aiming for the high goal had better be accurate, because underneath each high goal is a 1-point low goal for the opposing alliance. In addition to launching discs, robots can also spin the 4 rollers mounted to the field perimeter. Rollers are 250 millimeters long and 60 millimeters in diameter. If the area inside of a roller's pointers only shows one color, then that roller is considered owned by that alliance. Each owned roller is worth 10 points. Each match begins with a 15-second autonomous period, where robots operate without input from their drivers. In addition to competing for the autonomous bonus, each alliance also has the opportunity to earn an additional autonomous win point by owning both rollers on their side of the field and scoring at least 2 discs in their high goal. The 1-minute 45-second driver control period begins once the autonomous bonus winner has been determined. During the driver control period, robots can pick up discs from the ground or receive match load discs through the loader. As the clock winds down, it's time for the end game. At the end of the match, alliances will receive a 3-point bonus for each tile their robots are covering. So, during the last 10 seconds of the match, there are no horizontal expansion limits. VRC Spin Up can also be played in robot skills challenges where one team competes against the clock, the collegiate level VEX U competition where teams design 2 robots using advanced materials, and the VEX AI competition, a completely autonomous competition using industry-level machine learning technologies. Plus, there are remote options available for teams who want to compete from home. Check out the game manual or talk to your REC Foundation manager for all the details. Official rules and game information for VRC Spin Up can be found at roboticseducation.org or vexrobotics.com. To register a team, find events near you, or ask a question on the official Q&A, please visit robotevents.com. Best of luck and have a great season.
Welcome back. The VRC spin-up field consists of the following elements. The disc is a yellow foam object that can be used for scoring. There are 60 discs, 8 that begin as preloads, 4 per alliance, 14 matchload discs, 7 per alliance, 38 on the field at the beginning of a match. There are 4 rollers with cylinder shape, red and blue color, and can rotate, which are mounted on the field perimeter that can be owned to score point. Each roller has 2 pairs of pointers that, when viewed from above, indicate which lies on the roller. The high goal is a basket-shaped field element where robots can score discs. The color of the high goal indicates which alliance receives points for discs scored in that high goal. There are 2 high goals, 1 per alliance, 2 nets, 1 behind each high goal to keep the discs in the field, and 2 loaders, which are metal wraps, 1 in front of each alliance station, that can be used to introduce match-load discs. We can refer to the field layout for the initial setup of discs and rollers. Next is game-specific definitions. Except the disc, roller, high goal, loader, and net we have talked about, there is autonomous line. It's a pair of white tape lines that run diagonally across the field. Logo, the green highlighted regions in the figure, where robots can score discs. The logo is defined as the space in each corner of the field directly beneath each high goal, bordered by white tape lines, the field perimeter, and barrier. The white tape lines and barriers are considered part of the logo, and the color of the barrier indicates which alliance receive points for discs scored in that logo. Alliance station is the yellow highlighted regions where the driver team members must remain for the duration of the match. Starting line, 1 of the 4 white tape lines placed vertical to the field wall and used to determine robot starting locations. And one more important definition is endgame. That's the final 10 seconds of the match. Then scoring. Each disc scored in the high goal is worth 5 points. Each disc scored in the low goal is worth 1 point. Each owned roller is worth 10 points. Each covered field tile is worth 3 points. Winner of the autonomous bonus will receive 10 points. Next are important rules. First are scoring rules. SC2. A disc is considered scored in the high goal for the corresponding alliance color if it meets the following criteria. A. Not contacting a robot of the same color alliance as the high goal. B. Not contacting the green or black supporting structures underneath the high goal. C. At least partially contained within the vertical projection of the widest portion of the bottom basket of the high goal. Let's see the figures here. The first one shows the 3D volume in which discs are considered scored in the high goal. All the discs in the second figure would be considered scored in the high goal for the red alliance. In the last figure, disc A would be considered scored in the high goal. Disc B would not be considered scored because it is contacting one of the supporting structures underneath the high goal. SC3. A disc is considered scored in the low goal for the alliance corresponding to the color of the adjacent barrier if it meets the following criteria. A. Not fully supported by a robot of the same color alliance as the low goal. B. At least partially contained within the vertical projection of the low goal. C. Not contacting any field tiles outside of the low goal. D. Not contacting the net. E. Not contacting the high goal or any of the supporting structures underneath the high goal. Please note that discs which are scored in the high goal may not also count as being scored in the low goal. In the figure here, the green highlighted discs B, D, E, F, G, and I are all considered scored in the low goal. The red highlighted discs are not considered scored, because disc H is being fully supported by a robot of the same color alliance as the low goal. Disc A, C, J, and K are contacting the green foam tiles outside of the low goal. SC4. A roller is owned by an alliance if when viewed from above. The area between the roller's pointers is entirely that alliance's color. The first roller is owned by blue alliance. The second roller is not owned by any alliance. The third one is owned by red alliance, even though the boundary of the red and blue is right underneath the pointer. The owned status of roller can be changed anytime during the match. SC5. A field tile is considered covered if it is being contacted by a robot at the end of a match. A. A field tile may be covered by both alliances. B. Each alliance may only receive point for one cover per field tile, regardless of how many of their robots are contacting that field tile. C. The field tiles located in the logo do not count toward cover point. D. Covered field tiles are only count for point at the end of driver-controlled period. They are not scored at the end of the autonomous period. The two figures depict the same scenario. In the figure 1, the wheel of blue robot 1 are contacting 4 different tiles, and its horizontal expansion, highlighted in green, is contacting 1 additional tile. Blue robot 2 is entirely within 1 tile that is already being contacted by blue robot 1, so the blue alliance would receive 15 points for covering 5 tiles. In the figure 2, red robot 1 is entirely within a single tile. The left wheels of red robot 2 are being lifted off the ground by the blue robot 1's horizontal extension, highlighted in green, and are not contacting any tiles. The rear right wheel of red robot 2 is contacting the same tile that red robot 1 is already covering. The front right wheel of red robot 2 is contacting 1 additional tile, so the red alliance would receive 6 points for covering 2 tiles. SC6. The autonomous bonus is awarded to the alliance who has scored the most roller and disc points at the end of the autonomous period. Besides, an autonomous win point is awarded to any alliance that owns 2 rollers and has scored at least 2 discs in the alliance-colored high goal at the end of the autonomous period. Covered field tiles are not included in the determination of the autonomous bonus. If the autonomous period ends in a tile, including a 0-0 tile, each alliance will receive an autonomous bonus of 5 points. Safety rules and general rules. Safety first during an event. S1. Robot operation or team action should be safe during the match. S2. Robot should stay inside the field. S3. Wear safety glasses to protect your eyes. Then general game rules. G1. Treat everyone with respect. All teams are expected to conduct themselves in a respectful and professional manner while competing in VRC event. Teams, coaches, parents, and event staff should treat each other with respect. G2. VRC is a student-centered program. Some amount of adult teaching and guidance is expected and encouraged, but adults may never work on a robot without student on that team being present and actively participating. G3. Use common sense. When applying the rules in this menu, common sense always applies in the VEX Robotics Competition. G4. Robots begin the match in the starting volume. At the beginning of a match, each robot must be smaller than a volume of 18 inch, long, wide, and tall. G5. Robots may not intentionally detach parts during the match or leave mechanisms on the field. G6. The robot must represent the skill level of the team. Each team must include driver team members, programmers, designers, and builders. No student may fulfill any of these roles for more than 1 VRC team in a given competition season. G11. All rules still apply in the autonomous period. Teams are responsible for the actions of their robot at all times, including the autonomous period. G12 VRC Spin-Up is intended to be an offensive and interactive game. Some incidental tipping, entanglement, and damage may occur as a part of normal gameplay without violation, but strategies aimed solely at the mentioned interaction of opposing robot are not allowed. G14 You can't force an opponent into a penalty. Intentional strategies that cause an opponent to break a rule are not allowed, and will not result in a violation for the opposing alliance. G15 No trapping for more than 5 seconds. A robot may not trap an opposing robot for more than 5 seconds during the driver control period. Please note that there is no penalty for trapping during the endgame. G16 Don't cap your robot to the field. G17 Use discs to play the game. Discs may not be used to accomplish actions that would be otherwise illegal if they were attempted by robot mechanisms. SG1 Starting a match. Prior to the start of each match, the robot must be placed such that it is A. Contacting at least one of the green foam field tiles adjacent to the field perimeter that are between a pair of starting lines on the alliance's side of the autonomous line. The red and blue highlighted area in the figure shows the field tiles that the robot needs to contact for the red and blue alliances. B. Not contacting any other green foam field tiles. C. Not contacting any discs other than the preloads. D. Not contacting another robot. E. Not contacting any field elements such as the barrier or the net. Contact with the field perimeter is permitted, but not required. F. Contacting no more than 2 preloads. G. Not contacting any green foam field tiles inside the logo. H. Within the required starting volume. SG2 Robots get 2 preload discs prior to the start of each match. SG3 Stay away from the net. Becoming entangled with the net will result in a disablement. It's an exception to G14 because entanglement with the net is a potential safety concern. A robot which becomes entangled must be disabled, regardless of who was at fault. SG4 Horizontal expansion is limited until the endgame. Robots may not expand beyond a horizontal area of 18 inches long and wide at any point during the match prior to the endgame. But there are no horizontal expansion limits during the final 10 seconds of the match, so teams can expand their robots during this period to cover as many field tiles as they can. SG5 Vertical expansion is limited. Robots may expand vertically within the following conditions. A. The robot must not be contacting the green field tiles in either logo. B. No part of the robot may exceed an overall height of 24 inches. The intent of this height limit is to prevent mechanisms from extending above the bottom half of the high goal, which is roughly 25 inches from the foam field tiles. The supporting structure of the high goal is roughly 18.5 inches in height. A robot that has not extended vertically should be able to drive under it without contacting it. C. Any extensions or combination of extensions above 18 inches must fit within a vertical cylinder 2 inches in diameter. The inner diameter of a roller is roughly 2 inches and can be used to check robot compliance with Part C. Let's see the examples in the two figures. In the figure 1, both robots for Red Alliance are in violation of SG5, because the left robot is contacting the field tiles in the red logo, and the height of the right robot is over 24 inches. In the figure 2, the blue robot is in the red logo, but its horizontal and vertical dimension is less than 18 inches, so it's in legal size. The height of the red robot is over 18 inch, but less than 24 inch. The extension can fit within a vertical cylinder 2 inch in diameter, and it is outside the red logo, so the red robot is in legal size too. SG6. Match load discs may be safely introduced during the match under certain conditions. Match load discs may only be introduced once the driver control period has begun by a driver team member, and their hands should never break the plane of the field perimeter. SG7. Robots may not have a greater than momentary possession of more than 3 discs at once. SG8. Don't cross the autonomous line. During the autonomous period, robots may not contact four tiles, discs, or rollers which are on the opposing alliance's side of the autonomous line. It is expected that discs which are launched as a part of normal autonomous gameplay will contact four tiles on the opponent's side of the field, and this is not a violation. However, holding a disc over the autonomous line to manipulate an opponent's roller would still consider a violation. The 14 discs which begin the match on the autonomous line are not considered to be on either side, and may be utilized by either alliance during the autonomous period. SG9. Keep discs in the field. Teams may not intentionally remove discs from the field. Discs that leave the field during match play will be returned to the field at the location nearest to the point at which they exited. Next are the key inspection rules. R1. 1 robot per team. R2. Robots must be a representation of the skill level of the team. This is also mentioned in the general rules G6. Here is to emphasize that robot must be designed, built, and programmed by members of the team, not adults or members from other teams. R3. Robots must pass inspection before a match start. R4. Robots must be safe. R5. Robots must fit in a sizing box, that is a volume smaller than 18 inch long, wide, and tall. R6. Robots are built from the VEX V5 system. R14, 16, and 17 is the limitation of robot brain, motors, and pneumatics. Robots must only use 1 V5 robot brain, up to 8 V5 smart motors, and a maximum of 2 legal VEX pneumatic air reservoirs. R20. No modifications to electronic or pneumatic components are allowed. R25. Use the competition template for programming. Since the match includes both autonomous period and driver control period, teams must use a provided competition template or function equivalent to accomplish this and make sure the match plays smoothly. Now it's Robot Skills Challenge. The field setup for Skills Challenge is almost the same as head-to-head spin-up match. The only difference is that in programming skills matches, the VEX GPS code strip must be installed on the field, and the 6 preload discs for the other 3 teams are not used. RSC1. Robots may start the Robot Skills match in any legal starting location for either alliance. All driver team members must begin the match in the alliance station which corresponds to the chosen robot starting location. Robots must meet all the criteria listed in Rule SG1. The team gets 2 preloads that must be used in accordance with Rule SG2. If team wishes to use the preloads as match load discs, they may be added to either alliance station. The 6 discs that would be used as preload by other teams in a head-to-head match are not used, and all rollers on the field start on blue. RSC2. The team may utilize 14 match load discs within the guidelines set forth by SG6. 7 match load discs begin the match in each alliance station, just as in a head-to-head match. Match load discs must be introduced from the alliance station in which they begin the match. At any point during the match, one driver team member is permitted to move between the two alliance stations for the purpose of introducing match load discs. There may never be more than one driver team member outside of the alliance station in which the team begin the match. RSC3. In robot skills matches, team plays as if they are on neutral alliance. Robots may freely move on the field, utilize any loader, score in any goal, and manipulate any roller. RSC4. Robots must have moved during the match in order to receive points for covering field tiles. RSC5. Rollers are considered owned if they are read up at the end of the match. A team score at the end of a robot skills match is calculated by combining the scores that would have been awarded to the red and blue alliances. For example, all discs that end the match in either high goal are worth 5 points each, regardless of which side of the field the robot starts on. Next, I would like to introduce VEX program. VEX is for college team and uses the VRC spin-up field with no modifications. Instead of a two teams alliance format, VEX match will be played 1 vs 1. Each team will use 2 robots in a match. The qualification and elimination matches will be conducted in the same manner as in a VRC tournament, but in 1 vs 1 format, without an alliance selection. The autonomous period at the beginning of each head-to-head match will be 45 seconds, and the drive control period is shortened to 75 seconds. Teams must build 2 robots. At the start of the match, one must be smaller than 18-inch long, wide, and tall. The other one must be smaller than 15-inch long, wide, and tall. Teams may use any official VEX Robotics product, other than the exceptions in this rule, to build their robot. This includes those from the VEX Pro, V5, EXP, IQ, and Go product lines. Fabricated parts are allowed for VEXU and may be made using the process of ending, removing, bending, casting, or molding material, or attaching materials to one another. But fabricated parts must be made from raw materials. Teams may use commercially available springs and fastener on their robots. Each robot must utilize exactly one V5 robot brain microcontroller and exactly one V5 robot radio connected to a V5 controller. There is no restriction on the number of V5 smart motors that robots may use, and no restriction on sensors and other additional electronics that robots may use for sensing and processing, other than the exceptions in this rule. No radio communication is allowed between robots. However, other non-radio forms of communication are permitted. At last, teams may utilize an unlimited amount of the listed commercially available pneumatic components. Robot Skills Challenge for VEXU. The only difference is that VEXU teams are permitted to use both their robots in skills matches, and each robot must use its 2 discs available as preload, or add them to the team's match load discs. Both robots must start on the same side of the field, and all driver team members must stand in the corresponding alliance station. Okay, my introduction is come to an end. For more information of VEX competition, please contact us by the email address here. Thank you very much.
So thank you very much, Jason. We will next go into the VEX Go and Factory Automation Competition Program introduction, and then we will go into the Q&A. So thank you for your questions. We will get to them right away. Thank you.
Hey, welcome back. In this session, we will talk about VEX Go Challenge and Factory Automation Competition, FAC. VEX Go competition is a classroom-based competition, and is played on a 3 feet by 6 feet field. Teams compete in a robot skills competition where one robot takes the field to score as many points as possible. These matches consist of solo driving skills matches, corporate driving for 2 teams, and coding skills matches, which will be autonomous with limited human interaction. There are 4 missions: Mars Math Expedition, Village Engineering Construction, Ocean Science Exploration, City Technology Rebuild. Coaches will select one of the VEX Go competitions. Students new to robotics should start with Mars Math Expedition. Match scoring. Every completed task is worth 1 point each, so the scorekeeper may simply count each task to determine the score for each match. We provide scoring options and time options for coaches. When the coach uses the scoring option, they can count total of all points scored by the team for multiple rounds, or total points scored divided by number of rounds played, and they can also drop the lowest scoring round and then calculate with either method. When the coach uses the time options, they can use cooperative driver skills match lasts 1 minute, or solo driver skills match lasts 2 minutes, or coding skills match lasts 1 minute, or the coach can also use stopwatch method, which means start timer. Robot scores as many tasks as possible. Then, end time is recorded and factored into the team score. The VEX Go competition robot must only have 1 robot battery, only have 1 robot brain, and be made of only VEX Go parts. When compete, the robot must have the VEX Go license plate with team name or number. Decorations are allowed. VEX provides introduction for building basic robots. We call it hero robot. As the students spend time building and using the hero robots, they will be more capable of making improvement and building robots from scratch. Let's see the detailed tasks of each game. The first one is Mars Math Expedition. The Mars theme was co-developed with NASA. The field is perfect starting point for students new to robotics and competitions. All the tasks are designed to be achievable with basic robots, while leaving much room for improvement in robot capabilities and performance. The space theme provides relevant topics for discussion and exploration by the whole classroom. The tasks are: collect samples from the 3 craters, take samples to the laboratory for analysis, rescue the small rover that is stuck in the sand, realign the solar panels for better efficiency, clear the landing platform for the Mars drone to land, position the lunar spacecraft for takeoff, deliver fuel pods to the spacecraft and drone. Village engineering construction challenges students build robots to assist in building homes for a new village, while helping to set up critical infrastructure. These medium difficulty tasks are a great second-level competition for STEM students learning VEX Go. The tasks are: lower the bridge so the robot can cross the river, collect home parts from the waiting trucks, bring the parts to the human assistant for assembly, move completed house to the village, help lift the water tower into place, turn the water service on, Set up the wind generator so the village has power. Move the crops to the machine for processing. The ocean theme challenges students build robots to assist humans in exploring the bottom of the sea. These tasks increase the difficulty for robot design and capabilities for more experienced VEX Go students. The theme provides many real-world topics for students to discuss and explore as they build new robots for a new competition. The tasks are: set up temperature sensors in the undersea volcano, deliver camera equipment to the explorer studying fish, navigate past the current generators without damage, position the oxygen monitor in the kelp forest, maneuver rough terrain to finish an underwater pipe, carefully open the giant oyster to retrieve and pearl. The City Technology Rebuild challenges students to assist in restoring a city after a storm. Robots are the best way to navigate the debris and make repairs that would be dangerous for humans. This is the most difficult competition, requiring students to design robots with more functions and higher capabilities. The tasks are: clear the roads for fallen trees, open closed gates to access more roads, lift fallen power poles with live power lines, deliver medicine from the docks to the hospital, assist in the setup of a human shelter, deliver food and supplies to the shelter. Each mission can be divided into 4 stages. The stages introduce the game, scoring, rules in increments. Stages allow the students to focus on their robot buildings on a subset of the tasks. We recommend the coaches follow the steps to get started with VEX Go competition. Step 1. Select a mission. Step 2. Read the story. Step 3. Build part of the field. Step 4. Build a robot. Step 5. Practice driving. Step 6. Practice the competition. Step 7. Build the next stage. Step 8. Hold a competition. The next part is Factory Automation Competition, FAC. The Factory Automation Competition Delivery Design is a classroom-based competition, where teams will compete to achieve the best throughput and runtime at different competition phases. Students will design, build, and program a manufacturing work cell to complete the competition phase. Participants will compete by submitting a video of production run to robotevents.com, and their scores will be recorded on a global leaderboard. Teams from across the world will compete in their classroom to achieve the highest global rank based on their score at each competition phase. FAC Delivery Design Game consists of the following objects. There are 36 discs in total, including 12 red, 12 blue, and 12 green discs. 3 loading docks, including 1 red, 1 blue, and 1 green, and 1 disc feeder. There are 4 competition phases. In Phase 1, teams should deliver and sort all discs by color to the correct loading zone. All red discs should be placed in loading zone 1. All blue discs should be in loading zone 2. All green discs should be in loading zone 3. In Phase 2, teams should deliver and sort all discs by color to the correct loading zone and deliver discs in stack of 3. In Phase 3, Teams should complete the tasks in Phase 2 and must complete each loading zone in order. That means all red should be delivered first, blue the second, and green the last. In Phase 4, teams should deliver and sort all disks by color to the correct loading zone, deliver disks in stack of 3 and in the following order: all green on bottom, all blue in middle, and all red on top. Production runs are scored by achieving the best throughput and runtime. Teams get 1 point for each disk that is placed in the correct loading zone. Teams get a bonus of 5 points when they complete a loading zone without a mistake. Teams receive 3 points for each completed stack in the correct loading zone. For the runtime scoring, teams get 10 points for completing a production run in under 5 minutes. Teams get 20 points for completing a production run in under 3 minutes. Teams get 30 points for completing a production run in under 2 minutes. However, scoring is different at each competition phase. In competition phase 1, each disk that arrives at the correct loading zone is worth 1 point. In competition phase 2, each disk that arrives at the correct loading zone is worth 1 point, and each stack is worth 3 bonus points. In competition phase 3, each disk that arrives at any loading zone is worth 1 point. Each correct stack is worth 3 bonus points. If all red disks are delivered before any other color, then the team can receive 10 bonus. If all blue disks are delivered after all red disks have been delivered and before any green disks, this team will get 10 bonus. If all green disks are delivered after blue and red disks, then this team will get 10 bonus. In competition phase 4, each disk that arrives at any loading zone is worth 1 point. Deliver all disks in stack of 3. Each stack in the correct pattern is worth 10 bonus points each. The VRC Foundation has created a ranking system to allow teams to compete against themselves as well as other organizations. Teams will film a video, record a production run with an explanation of the process and how they function to achieve the competition phase challenge. In order to rank globally, teams must upload a video submission of their production run. This video will be used to verify score. Teams must start at competition phase 1. Complete all the tasks in phase 1, submit a production run, and receive a score verification before they can go to the next competition phase. Teams are ranked within each competition phase based on the number of the points scored. Ties in team ranking will be determined following an order. In order to participate in the factory automation competition, a team must first register on robotevents.com. Upon registering, they will receive their FAC team number to display on their team ID plates. That's all for this session. Let's go to the Q&A session. Thank you.
Great. Okay, well, thank you everybody for being so patient. We just wanted to address the wonderful questions and give you some answers. So we will now pass the question about registration to the events team.
Okay, I can answer the question about this team registration. So if you usually the organizations within a single REC Foundation program are defined by the location of the school. So if a group or an organization have several schools in the same city, but those schools are located in different locations. So normally we should consider those schools as different schools. So, but if you are not sure about this such kind of definition, please send us more details so we can review it, and we also can check with REC for a more clarification. And for the next one is if a school is the next question is if the school has 3 teams, how much they should pay. So we should consider if the 3 teams are on the same competition platform. So the first team is $200 US, and the second, the third, and the fourth teams are $150 each. So if the school has 3 VRC teams, for example, you need to pay $500 US for the 3 teams. But if they are actually are on the different platform, so like 1 VIQC and 2 VRC teams, so this school should pay $200 for the VIQC team, and 200 plus 150 for the 2 VRC teams. So that's my question. That's my answers.
Great. Thank you so much, Crystal. Now, there was another question about game elements. I just wanted to let everybody know that game elements, those change every season. What goes inside the field changes. What is the field doesn't change very often. So a great question was brought up about what are the game elements, because I want to order them. I don't have them just yet. The foam disc is one of the game elements in Spin Up, and we do have in our game manual the dimensions and the weight and the thickness of the foam disc. Now, something like this is still going to be very hard to 3D print. It'd be very difficult to 3D print something with the durometer, the softness of foam. But you could create something here that is pretty very close to the diameter and the thickness, and then you can be able to figure out the weight as well. So I will send that in the chat so that you have that, and you can access it from the game manual. If there are any other questions, please don't hesitate to ask us. I just wanted to also mention is that if you do want to ask a question, it pops up after this webinar. We are available via these email addresses. And if there's any questions about education and training, of course, please reach out to Kelsey. She can be reached at ap-info. So if there's no other questions, I think we will stop recording, and we will share with you a post-event survey, and there we'll also have a link to the recording of these videos so that you can access them at your leisure later and share them with others. Please follow us on Facebook. Please follow us in our YouTube channel. If there's any questions in the future, please don't hesitate to contact us, and it's very nice. Thank you all.
Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Okay. Have a lovely evening, everybody. Thank you.
Thank you.